From 9 a.m.
This is Views and News with Clarence Ford.
Only on Cape Talk.
It is the Naked Scientist and your questions. Welcome to Cape Talk again on a chilly little misty morning, but it's a bit of a respite from the hot weather that we have had and will have for next week. Dr. Chris Smith, good to have you back.
Speak for yourself, Clarence. It's pretty cold and miserable here. So we had our 40 degrees. We've now gone to, it feels like 40 below. Pretty horrible, but you're making me jealous with your warm weather.
It's a miserable 24 degrees.
Thank you. That makes me feel so much better. Talking of weather, we talked last week about ball lightning and this interesting phenomenon that sometimes happens, has been reported in various media and so on. Someone called Linda has been in touch with me because she said, I'm writing about the recent episode of the programme. She's in Canada and she actually listens on the internet. And she said, I'm writing about your recent programme with one of the questions about ball lightning. I was 7 years old and my relatives were living in Gibsons, British Columbia. They had a fire in their house. Lightning had hit their TV antenna. They said a round ball had come out of the TV, smashing through the glass front. It bounced around the living room and started a fire in a chair and then went out through the picture window facing the ocean. The house was on the ocean front. Here's a link to the local newspaper. And she sent me from the University of British Columbia archives, the newspaper from 1957. So we now also know how old Linda is. Beautiful to have that story. And so it doesn't explain obviously what the phenomenon is, but it was great to have that report, independently of someone having, had first-hand family experience of this happen to them.
Yes, indeed. Just maybe on the topic of weather as well, we've seen some pretty adverse weather events in the Northern Hemisphere in the USA, and I think some reports coming out of Europe as well. We've seen some hectic stuff in our country as well. Lots of rain and flooding and devastation. Are we going to see more of these adverse weather events given the global warming situation?
Well, that's the theory, because the idea is that weather is a manifestation of climate, and it's a product of the energy distribution in the atmosphere. And the more energy you put into the atmosphere, the greater the pressure differences that you can create in the atmosphere, and therefore the greater the driving force behind storms. There will be more water locked up in the atmosphere because if you have higher global temperatures, you evaporate more water off the ocean surface. You've got more energy embodied within that water and more rainfall embodied within the atmosphere, so you can intensify storms. And the patterns that we have, there are various ways of inferring what the weather was doing way back in history. I interviewed one group of researchers, it was about 20 years ago almost now, and they had been looking at the build-up of gravel in various parts of the ocean. And when you have really big storms, you can move bigger objects than if you have smaller storms. And so you can use the layers and the thickness of those layers and the size of the particles in the sediment layers to work out how rough the storms must have been when they happened. And they can see a trend there suggesting that, exactly as we're saying, that you get an intensification with a rising temperature. And so if you take climate change to its endpoint that we predict we're going to reach at the present values, yes, we would expect to see quite a considerable impact on weather. Some parts of the world's surface becoming a lot drier, but some parts becoming a lot wetter. Some parts becoming a lot hotter, some parts becoming a lot colder. The overall sort of impact of that is that the livable land area where we can make our home and feel comfortable could drop considerably in the future. And if we feel compelled to move, then animals are also going to feel compelled to move. And that means there may be more conflict with wildlife. And then we're into a whole realm of, well, are there diseases in the animal world that could jump into us humans? And so we've got to think about that. Yeah. So it's not just about what the weather's doing. It has all kinds of ramifications and domino effects for all kinds of different aspects of science.
Now to a very different question. Why does a runny stomach, gout, toothache, etc. always seem to catch you during the night?
Well, there are some diseases that do manifest more often at night. And there are various reasons for this, because the human body follows a circadian clock. And we have this 24-hour almost cycle to when we get up in the morning, when we go to bed at night, when we sleep, when we wake, when we feel hungry, when we feel tired, when we feel most awake. And this is because we have a clock ticking in our brain, a master clock ticks in our brain, and in every single part of our body there are individual body clocks called slave clocks, which are listening to that master clock and aligning themselves with it. And so, unsurprisingly, because they affect metabolism, they affect the way different parts of your body work, there are some conditions linked to how those cells are working and what your blood pressure is doing, what your blood sugar is doing. There are therefore some conditions that will be manifest more often at certain times of the day. There are some treatments that will work better when administered at some times of the day compared to other times of the day. But when it comes to more random things, stuff like a dose of norovirus that will give you DMV, then a virus doesn't care what time of the day it is. It will infect you. It will infect you, and it will tend to have a certain time course for that infection, because the infection comes along, it revs up your immune system. Your immune system responds by making you feel ill, throw up, have diarrhea, whatever. Sorry, I know it's breakfast time. And then you recover quite promptly. So some things aren't going to be quite so linked to the body clock, but we might notice them manifesting because they're so different to the usual. Now, it's not normal that you throw up, of course, but if you're normally asleep and it wakes you up, gets you out of bed and then keeps you up all night, it's going to make you feel so ghastly. You're going to remember that, and you're probably going to remember that more than the time that you just felt a bit queasy during the day, had to discreetly take yourself off to the loo a few times, and then you thought, oh, I had a horrible day, but then I felt better after a good night's sleep. So some of this is because there really is a body clock and time-related phenomenon for some conditions. Some of it is because it just happens to happen at night, and you notice it because it's so different. You'd normally be asleep, and it disturbed your sleep and made you feel doubly bad.
Wow. Okay. That was a really great question and an even better answer. Then we have a voice noting. Let's take a listen to this one.
A question for the naked scientist, please, this morning. Why do the moons in your nails disappear as you get older? There was a group of 70-year-olds sitting around a table the other day, and none of us had moons in our nails.
Hello, Pat.
And I think all of us are checking out.
We're all looking. Yeah, we're all bending our fingers over and looking at palm woods to see what the moons look like. My nails are so shot to pieces I can't really tell. I've got a few there. What about you, Clarence? Have you still got moons?
They're rather pronounced on my thumb and half moons
yeah.
on others. Yeah.
Yeah, I've just done a lot of decorating, so I can't really see what's going on with my fingernails. But I've never been asked that, and so I don't know if it's true. Obviously, if there's an observation that it is, then it sounds like it is. Those half moons are the growth plate, where the groups of cells underneath the nail are laying down new nail material, which is then going to grow forward up the base of the nail and emerge from the tip of your finger as the little white bit. Nail is made of the same stuff as hair. It's keratin, the protein, and it's a white colour, and it's produced by a layer of stem cells that then produce more nail producing cells that then produce these filaments of this protein, which are then woven together to make your nails. That does change shape with age, with disease, with nutritional status, and the shape of your nails is also a reflection on your overall health. There are various soft signs that we look for as doctors in the shape of the nail, and when someone has something bad happen to their health, sometimes you will see a change in the structure of the nail, and you get almost like a tide mark. And as the nail grows out, you can see a groove or a ripple in a person's nails because, for instance, drugs that stop stem cells or cells growing rapidly have been given for, say, a cancer treatment, and it arrested the growth of the nail for a while, and then it resumed, and you get this tide mark or ripple in the nail. So that may be part of what's being described here, but also vascularity of the digits can change. As we get older, perfusion, the supply of blood to our distal extremities, can change, and the dynamics of circulation can change. And this can affect coloration of the fingernails. It can also affect how well vascularized and how quickly blood returns to the digits when you squeeze the blood out of them. All these things might affect the appearance of a fingernail, but I'm going to take this away as an observation. I'm going to ask my colleagues about this and see if we can get some consensus. So thank you very much for the thought-provoking question. I've not been asked this. I don't know just directly the answer, so I'm going to find out. Or if anyone else knows, like the ball lightning question, or you've got an experience, can you let us know, because we welcome your input too.
Andrew wants to know what the advantages of both a petrol or diesel car are.
Hello, Andrew. Well, they're two totally different types of fuel. In a petrol engine, what is going on is that the petrol gets pushed into the cylinder and mixed with air and compressed. And it's actually quite hard to make the petrol ignite with the compression in a petrol engine. It's a much lower level of compression, so it's less hot than in a diesel engine. And so the piston gets to the top, almost the top of the cylinder, before the spark plug sparks, and that spark initiates the burning of the petrol and air mixture that's been compressed. This burning produces a lot of heat, which heats the gas that's in the cylinder, and when you heat a gas it gets bigger, and therefore the pressure goes up in the cylinder and it pushes the piston down, and that's the power stroke. You get the energy out and off goes the car. A diesel engine works differently. It's much higher compression, so you take a big volume of air and you squeeze it to a very tiny volume, and when you squeeze a gas very hard it gets very hot. And at the point at which the gas has got really hot, when the piston's right at the top of its travel in the cylinder, the injector squirts diesel as a mist into that very, very hot but low volume, high temperature gas. And the diesel fuel then begins to burn, just like the petrol did, and it produces again a lot of heat, a lot of hot gas, and that hot gas increases the pressure inside the cylinder, driving down the piston. Because the two engines work differently, diesel engines are much heavier because they've got to take much higher pressures in the cylinder, and they also have a massive great flywheel to sustain that movement, and so they tend to rev much lower. So a diesel engine will be revving at a third of the revs of a petrol engine, and the torque of a diesel engine, when it's generating most of its power, will be at a much lower rate of revs than in a petrol engine. And because petrol engines are lighter, they tend to rev higher and they can accelerate faster, and this means that you've got a broader range of engine speeds over which you extract power, but on average the most power production will be at a higher rate of revs. And this affects the performance of the engine depending upon what task you're asking it to do and how high you need the engine to be revving to give you the sort of control that you want. Now, if you're driving a truck and you want to have long, sustained output with plenty of power, but you don't care if it takes a while to get to that top speed, then a diesel engine is great because it's not going to be wearing itself out very quickly because it's revving very, very low compared to a petrol engine, so you can have long service intervals, and they tend to last a really, really long time. If, on the other hand, you want something that's light because you don't want to make your car weigh twice as much, you don't want a huge, great, heavy, bulky diesel engine in there because you'd add enormously to the weight of the car, and that would affect your efficiency, so you put a much lighter, more agile petrol engine in a small family car. But the petrol engine will burn a lot more fuel because it's burning at a much higher temperature than the diesel is. The diesel, you'll get enormous efficiency because they're probably the best engines for efficiency you're ever going to get. Whereas petrol, you'll burn a lot more petrol to go the same distance. So it's horses for courses, and you have to weigh up what the costs are in terms of fuel costs, service costs, the weight of this thing, versus the simple practicality of having something light, something that is pretty easy to replace and work on, and therefore more suitable for certain applications.
We have a question from Frida. She writes, when you eat a carrot, is the head of the carrot top safe to eat?
I don't think there's a problem. I mean, if you're a horse, it doesn't seem to care. For us humans, those leaves are no different than eating salad leaves. I don't think there's anything particularly nasty in the leaves of carrots. I just don't think they taste that great. I'm not aware that there's anything toxic in the leaves of carrots. In some plants, you have to be careful. Rhubarb, for example, it concentrates a lot of oxalic acid in the leaves of the rhubarb. Oxalic acid can build up in your kidneys and cause kidney stones as oxalate stones. So we avoid eating the rhubarb leaves and you just concentrate on the stems. But I don't think there's the same problem with carrots, although the carrots are going to taste a lot nicer than the leaves do. So I'd concentrate on the orange bit.
And then maybe a question that I've been thinking about as well. I'm from Tony. For a long time, the Milky Way galaxy had 100 billion stars, but the figure was revised to 400 billion stars. Why was the number revised? Is there a rationale for the change?
Yeah, I read this recently because we'd always said, look, there's about 100 billion stars in the Milky Way, and there's about 100 billion Milky Way-like galaxies out there, so there's about 100 billion times 100 billion stars in the universe. And then more recently, you've begun to see estimates of between a couple of 100 billion and 400 billion stars in the the Milky Way galaxy? The answer is we're revising our ideas all the time, and there have been various experiments which have been launched which have done more accurate counts of the stars in space. We've got various space telescopes now that can see what we previously couldn't, and they've made more comprehensive surveys of the sky with a whole raft of science experiments, and including things like the Gaia Space Telescope. And these kind of images are giving us much more detail, and it means we can refine or constrain our guesstimations much more. No one knows that's precisely the right answer, but that's the right ballpark compared to where we were. We've got far more stars now visible to us than we thought there were before, so we've upped our estimate.
Right, we're chatting with Dr. Chris Smith, the Naked Scientist, an opportunity for you to ask a question that has kept you awake at night. Earth is a closed system, so it really gains or loses extra matter. Does the same water that existed millions of years ago still exist today or not? Malcolm.
Hello, Malcolm. The Earth is both gaining and losing mass, actually. It gains the weight of a couple of aircraft carriers worth of stuff raining in from space every year, but it's losing about 9 or 10 tons a second of mass to space in the form of very light gases like hydrogen and helium from the upper atmosphere, which are so light that the Earth's gravitational field can't hang on to them, so they're lost into space. So there is a kind of balancing act going on here. And the other thing to consider, we talked about climate change earlier on. The Earth is also becoming, on average, warmer because of the effects of climate change. And because E equals mc squared, if you increase E, the energy in the system, because the Earth as a system has got hotter, then the m, the mass, must go up to keep the equation balanced. So the Earth is getting heavier because it's getting hotter. But that's into Einstein's physics, so that's slightly peripheral to the argument. The water side of things, the answer is that there is both water that was here historically, but there's also new water. So let me explain. When the Earth first formed, there would have been some water which was part of the material that formed the planet when it coalesced from a ring of gas and dust around the young sun. There would have been some water in that. So the Earth had some water to start with, but most of the water we have on Earth arrived here from space subsequently. During the first billions of years of its life, probably the first 500 million years or so of its life, the Earth was bombarded by impacts from space of lots of asteroids and comets, and they brought to the Earth a lot of the water that we have here. And we know that because we can look at the ratio of what are called isotopes. They're different flavours of the same chemical, and oxygen has various isotopes. And you can look at the flavours of those isotopes and the ratio between them here on Earth, and you can then look at material out in space. And if you see the same sort of ratio there, it gives you a clue that probably out in space, those things brought water to the Earth. So there will have been some water that was brought way back in the planet's history, deposited here, and it's stayed as water ever since. But at the same time, some water is participating in all kinds of chemical reactions where you dismantle a water molecule and then reassemble it. And a good example of this would be if you take a glucose molecule in your body, sugar, C6H12O6, and you eat that glucose, your body will use some oxygen from the environment that you breathe in, and it will burn that glucose to produce some energy, 6 molecules of carbon dioxide and 6 molecules of water, because glucose has got a water molecule tied up to a carbon atom. And so the water was always in the glucose molecule, but now it's come out and become a water molecule that's free in the environment again, chemically speaking. So some of the water that's out around the planet is original. Some of it has been dismantled and the atoms rearranged in space and taken part in all kinds of chemical reactions. And so it's been rebuilt as water from other starting sources. So the answer is that some new water, some old water.
And I hope this question can be answered in about a minute, but it's a question that's also kept me up at night. Thank you, Thomas, for this question. What is the difference between being intelligent and being creative?
I think intelligence is required for creativity. Intelligence is your ability to use your brain to take in an environment or a situation and then work out how to solve a problem or to achieve a goal that environment has placed in your way, or an opportunity it's afforded you that you need to access. Creativity can therefore use intelligence in order to come up with your solution. So if you needed to find your way out of a hole, you may use the tools at your disposal, use your intelligence to work out how to use those tools, and be creative in order to come up with a solution that gets you out of whatever hole you've fallen into.
in exactly a minute. And we appreciate that, of course, the Naked Scientist.